Hi, so in this video, I'm going to show you how to do the standard algorithm for multiplying decimals, and I'm also going to explain to you why the standard algorithm works for multiplying decimals. And so we're going to start by doing this decimal problem. 26 and 83 hundredths times 4 and 3 tenths. So the first thing we need to do is figure out how we could make these into whole numbers. And so we see there are two digits after the decimal in this number. So we could multiply 26 and 83 hundredths times 100, or 10 to the second power, because there are two shifts, and that would get us the whole number of 2,683. So if we think about 4 and 3 tenths, how could we make that number into a whole number? So what we could do is multiply that just by 10, because it's only one shift to make it a whole number. And that's going to give us 43. So I'm just trying right now to give you a little bit of background about why the standard algorithm works. And so we multiplied these numbers total by 3 place values. We multiplied this one by 2 place values and this one by 1 place value. So we have 3 total place value shifts. So now we can take these two whole numbers and put them vertically, just like this. So 2,683 times 43. And we're just going to solve this with standard algorithm, just like they're whole numbers. So we're going to do 3 times 3 is 9. 3 times 8 is 24. 3 times 6 is 18, plus 2 makes 20. 3 times 2 is 6, plus 2 makes 8. Then we're going to add our 0 and do our next one. So we're going to erase the ones we carried over. 4 times 3 is 12. 4 times 8 is 32, plus 1 makes 33. 4 times 6 is 24, plus 3 makes 27. And 4 times 2 is 8, plus 2 makes 10. So we're going to add up these two partial products, and we're going to get 9, 6, 3, 15, 1, 1. So this number is 369. So if we write that number over here, and now we've made them into whole numbers by shifting our decimal 3 times. So we have to go back at the end and shift our decimal 3 times again to get our correct answer. So 26 and 83 hundredths times 4 and 3 tenths is 115 and 369 thousandths. Okay, so that's why the standard algorithm works. And so I'm going to show you another example about how we can use this method to solve multiplication problems with decimals. So this time we're going to do 62 and 43 hundredths times 6 and 8 tenths, just like this. And so now that I've showed you why that kind of works, I'm just going to show you a shortcut way to solve. So in this problem, there are 2 digits after the decimal, here and here, okay? In this factor, there's 1. So in this factor, there are 2 digits after the decimal. In this factor, there's 1 digit after the decimal. So total, that makes 3 digits after the decimal. So I like to write the number of digits after the decimal off to the side and circle it so I remember to come back to that. So basically, we could shift this 2 place values to make it a whole number, and this one 1 place value to make it a whole number. That's where we get that 3. So now I can just write my decimal numbers just like if they were whole numbers. We don't have to line up our decimals or anything because we're just pretending that they are whole numbers. Okay, so we're going to multiply and just kind of ignore those decimals. So 8 times 3 is 24. 8 times 4 is 32, plus 2 is 34. 8 times 2 is 16, plus 3 is 19. 8 times 6 is 48, plus 1 is 49. So then we're going to add our 0 just like we do with standard algorithm for whole numbers. And so now we're just going to multiply the 6 in the tens place. 6 times 3 is 18. 6 times 4 is 24, plus 1 is 25. 6 times 2 is 12, plus 2 is 14. And 6 times 6 is 36, plus 1 makes 37. So now I'm just going to add up these two partial products, ignoring my decimal so far. So I'm going to have 4. 8 plus 4 is 12. We have 9 plus 1 is 10, plus 1 is 5. 9 plus 1 is 10, plus 4 is 14. 5 plus 7 is 12. 3 plus 1 is 4. Okay? So now we've got this number at the bottom. But we had 3 place value shifts to start with. So we have to take our decimal, which is always at the end of a whole number. So we're going to take our decimal and we're going to shift it 3 times to get our product. So our final answer is 424 and 524 thousandths. We have 3 digits after the decimal in our product, and we have 1, 2, 3 digits after the decimal in our factors. So we know that this could be a possible answer. Okay, so we're going to do one more that's just a little bit different. So let's say we're just multiplying 17 and 8/10 times 4 and 5/10, just like this. Okay. So the first thing we're going to do is figure out how many digits are after the decimal in the factors. So we have 1 digit after the decimal here and 1 digit after the decimal here. So that's 2 digits after the decimal total. So I'm just going to write that up here. And what that means is we could multiply this by 1 power of 10 to make it a whole number, and this one by 1 power of 10 as well. So now I'm just going to write these numbers vertically. And remember, we don't necessarily have to line up the decimals because we're just kind of pretending they're not there. So 5 times 8 is 40. 5 times 7 is 35, plus 4 makes 39. 5 times 1 is 5, plus 3 makes 8. And then we have to add our 0. Okay. 4 times 8 is 32. 4 times 7 is 28, plus 3 makes 31. 4 times 1 is 4, plus 3 makes 7. So we're going to add up these two partial products. Okay. And it looks like we got 8,010. But we can't forget we have to shift our decimal 2 times. So we're going to move it over 1, 2. So our final product will be 80 and 10 hundredths, or we could go ahead and say 80 and 1/10 because 10 hundredths is equivalent to 1/10. Okay. So just to kind of recap, when you start a problem that you're going to solve using the standard algorithm, you can see how many digits are after the decimal in the factors. Then you can solve it as if they're whole numbers and then move your decimal. The same number of digits that are after the decimal in your factors will be in your product. So that is how you multiply decimals using the standard algorithm.